Hello, I will be your first speaker today. And I will, in a very confident voice, talk about you some things I learned about Google Cloud Build. And I wonder, how many of you are using a build system today? Most people, but maybe not everybody. Yeah, of course. Good question. Can somebody define what is a build system, if you know what I mean? Yes.
It's a monkey sitting in the basement pressing buttons. I'm just joking.
Yes, but it could be a better definition.
It grabs your code automatically and builds it for every now and then, every change.
Yeah.
Code comes in, the build binary goes out.
Yeah, exactly. And where do the binary goes out? And
Artifacts.
Artifacts somewhere.
Yeah, and what do you do with artifacts later?
You use them in your deploy them also.
Yeah,
deploy them, test them.
And that's all my slides. So yeah, so for those who are not using a build system or just use them a little bit to hear the word, the idea is exactly as these gentlemen described. So I call it 3 Docker containers in a trench coat. It's like your build system is CI/CD, and it's very, very frightening when you're a bit from it. But what it actually does, and it is really frightening when you're in it also, but it shouldn't be. Because the reason it's frightening is just because all the characters. The idea is that the theory behind what a build system is quite simple. So I don't think I know of any build system, which is not very many, I suppose, but not any build system that isn't just starting Docker container doing things, starting another Docker container doing something else, and then off you go, and then you do stuff. So if you think about it that way, that helped me to understand a little bit about it. Question?
But you're talking about the modern ones, right? Because the traditional ones that I've been working with do not use Docker.
There you go.
Yes, like me.
Exactly. So yes, like make. Yeah. If you consider build that the build system, which you should, of course, because it's the original build system. So there you go. But I'm so very young, you see. So I actually in the build system space. So the idea of this talk is not really to do a complete mapping of everything, but just to show you some hints about how Google Cloud Build works if you'd like to use it. So that's it. But the idea is quite simple in the modern sense. So if you heard about Jenkins, it's like that. And then you can also say, why should you use Google Cloud Build when everybody's used to Jenkins that all companies use? And my question is, yeah, sure, you can use Jenkins. But then you have to, but the thing is that then you have to configure it yourself and run it yourself and maintain it yourself. So the thing with Google Cloud Build, like any other, like Azure or AWS, have their own kind of integrated build system. And if you're not doing something really, really weird and special, or moving a garbage file to the cloud or something like that, so you have to have it included, then it's nice to just use what's included in the car. That's what I think.
What if you want to switch cars from Google to AWS?
That's a good point. You want to switch, exactly. So and that goes for any kind of service. So if you start doing something in Google Cloud that is tightly coupled to Google Cloud, then you have a lot of work to do.
Yeah, but it's not always like that, because you could do Docker containers and you can deploy it whenever you want. So you could do pipelines like builds like in AWS, Google doesn't matter. So you just deploy it. It does not rely on the services in the cloud.
Yeah, it depends on how you do it. But the thing is, but we can counter because I still think you have a lot of work to do if you have a large company, a lot of things. But that applies. I mean, it's the same trade-off for any kind of service, including this that you can talk of. So if you use the included stuff, you get very quickly up to speed. But then you're screwed if you want to move. And cool thing with having something included that you get kind of used to and then can't move from, and then pay Google more money instead of somebody else, is that it's really, really nice with all the secret managers and other kind of stuff. It's easy to deploy to things. Otherwise, we need to maintain something that is really, really movable for a long time. That'll take a percentage of code or time you could be coding instead. So I made my choice, but you will, of course, since I may, do something else. If somebody who's still interested in Google Cloud Build wants to know what it looks like, here's a pet project I made. It is some triggers. So this build system needs to be triggered to do these kind of things. Take your source code and build it, and then make something strange out of it, and then deploy that strange thing. And maybe other things like, testing, perhaps, who knows? And then you make this trigger. And now it gets tricky because now you can't see at the back. But if you could see at the back, you would see that There's a lot of configuration here. It's 2 screens actually, so you couldn't have seen anyway. And the interesting thing here is that you can connect it by magical means to the source code repository. And we use GitHub, and I use GitHub privately also, which I shouldn't, but I do. And then we connect something at GitHub, a GitHub app, which pushes any kind of branch to this magical system. And then it can react and say, should I do this? Should I do that? Which trigger should I do what? So I have a dev branch, I have a main branch, I have a testing branch or a QA branch, and different triggers can be triggered depending on which branch you're pushing to. So in essence, quite easy. There are a lot of other options which you will not use. You can have, of course, manual invocation could be interesting, and you can have pub sub messages, yada, yada, stuff like that.
Is there a Terraform provider for it?
It is.
Partially.
Or
There is, yeah.
So for the manual PubSub and that tool, there is no opportunity to Terraform, but the rest can be Terraformed.
And another thing, when you have a build system, is that stuff happens in these Docker containers, and you want stuff to be configured so they are partially reusable or at least easily interchangeable without compiling source code or changing anything. And the thing with these kind of build systems is that you want to have a file, Terraformish, I suppose, but not really, that tells the build system what to do, so you can configure it. Either you can edit it in line here, or you can have it as part of your source code repository, but you still want to give it some kind of dynamic data. So you have environment variables that you can just chuck in here, and you can have different triggers for different kind of environment variables, stuff like that. And I just want to note that these environment variables are not the same thing as secrets or stuff like that. And I actually had planned to talk about Secret Manager, but you see how good this is going, so it's good I didn't actually do that. But it's quite interesting. Is anybody using secret managers of some kind? Same people. Cool. Those of you who don't use secret managers can ask those people how it works. No, but I was going to say that the idea with a secret manager is that the stuff you have in environment variables, really, really important API keys, passwords, URLs that should be shared for some reason, and you have them now in source code or somewhere, and it's really awkward. That's the thing you do, put in the secret manager. And if you haven't used secret manager before, you will start trying to, like sleepwalking, use it inside your build system and kind of push it into environment variables, because you think that this is a good way of enticing your source code to behave. And this would I not recommend to do. So if you start using secret manager, the only way to do it, I would recommend, is to, in your actual program, pull down the secrets when you have started. Make it go a year or 2 years. Just some idiot with a beard told you something about this. So try it your first step, so you can save some time. Or listen to another.
sometimes build systems, if you don't define secrets, they might log output things because they don't know their secrets.
Oh,
Yeah.
And you don't want your secrets in your log.
Yeah.
Okay, fair enough. It's a good discussion anyway, but the way we use it, it works very well just to.
I mean, I imagine the secret manager is integrated, therefore it won't log out secret manager stuff.
It won't log out anything that you don't explicitly log out. But yes, it's integrated to Google Secret Manager, and if you don't explicitly spit something out, it will not do it.
Yeah.
But there is also, so in Google Cloud Login, you could plug in something called DLP, the Data Loss Prevention API, and so you could instruct the login system to obfuscate any secret data. So it could be personal number, social security number, passwords. It has like a built-in model, machine learning model to detect stuff. And before it writes them to logs, it just like replace them with XXXX. So
That sounds too good to be true, but yeah.
DLP, DLP, data loss prevention. Yeah, it's a Google thing.
I don't mark the data. It detects.
Yeah, it's automatically detects. It has machine learning trained for all various types of data in various parts of the world.
Sounds very magic. But
It can recognize actually personal number, Swedish personal number, for example.
maybe you can show or get back to that when you.
Yeah.
Because no, but we haven't used them, so we should. Anyway, if you are configuring your build system using a source code-ish file, and this will not be visible to anybody, but the idea why I want to show a little bit of this, which you can't see by the way, is a YAML file if it were correctly configured. And here you describe the different kind of things Docker container the trench code. So you define the build steps, And at this point, when you kind of make the build system execute your configuration file, you have your source code get it magically from your source code repository, and then it can build it, you can test it, you can have test coverage and all those things. And at the end, you probably deploy it. Question?
Which repository services does it support? Because I assume it's supposed to go to the cloud one. What else does it support?
Any publicly available GitHub?
Git, suppose Git.
Any public available GitHub, yeah.
But I only configured the GitHub app to use
So it
it.
supports GitHub, it supports
Git-
GitLab, it
GitLab.
supports Google Cloud repositories, but basically anything that it can talk to on the internet. If you have self-hosted GitHub, for example, that wouldn't work.
Okay.
Reforce, SVN?
No, just Git.
No. So I'm gonna be the crazy guy who's gonna try to connect it to the Azure DevOps Git for the hell of it.
If it can talk to it,
Yeah,
it
it
can
can.
flow from
It's a good
the-
idea. And here, another thing is when you're doing this kind of build system thing, which is very complicated, I've heard, it can take a while. So it can take like 8 minutes, 12 minutes, 15 minutes, 20 minutes, depending on what kind of language you have and what you're doing. And then I discovered something called the Kaneko cache, which is, have everybody used the Kaneko cache? No, no one? Okay, well, thank you. That is when you compile, when you create, Docker containers locally, if you only change the last part of the Docker file, then it only, effectuates those changes. You don't have to recreate the complete Docker file specification from scratch. But when you're creating a Docker container in the cloud, inside the build system, then you're not at your local computer. So it's create a Docker container environment for you, and then you have to do every step from scratch. It's very, very hard. And Kaneko cache, in a nutshell, is this. It actually is a cache for the Docker builds.
What if it has multi-stage processes, like multi form statements?
It works. I actually have that. I have one of those, and it works with that as well. So it's kind of hard the first time when you change from app to get stuff, but just your source code just does that. So it works just as a Docker build, but quicker. So it's Question?
But what about the resources, the actual container? Can you adjust that somehow?
What do you mean by
Using
resource?
CPU and RAM, because that's mostly what
For the build system?
Yeah.
You can configure that, yes.
Okay.
But I actually didn't see those options. I actually had to check that out this morning because I also figured out we just use it and then it's sort of slow. So you can also pour more money on it and make it go quicker.
Yeah, because that's usually how it works, and then how
Yeah.
that is
Yeah.
up to the build system. But so basically, you can get a more powerful box.
Yeah. Of course. Or do this. Or both. So
If you are building local containers, technically what takes time is actually pulling the layers. It's not the how big is the box where the execution happens, right?
Well, if it's a complicated build, it is. We're talking
If you're doing something local like C++, something like that, yeah, then yes, I agree. But what takes time usually in cloud build is pulling the code if the code base is too big. If you're using a monorepo, cloud build will be too slow for you.
Okay.
Because it will be dumping the whole thing. It does a git clone. So a git clone, basically cloud build, what it does, it starts a Docker container called the workspace, which you don't see. And inside of it, it executes all your build, right? So starting that first Docker container is quick because we catch it, we have it, it's our system, right? Then inside of it will clone the code first. So if your code is big, it will take time. And then for each layer, because each layer is a Docker container.
Yeah.
So technically it's Docker in Docker, it's executes Docker inside of Docker. So those, the builders, as they call, those are quick to pull because they're hosted in our repository and they're like distributed. But if your Docker file has from Node.js, from something, that could take time.
But it is actually cached in this Kaneko cache also.
If you use Kaneko cache, yes, it will cache. Yeah. Without Kaneko, then
it goes as usual.
exactly.
Yeah. Yes.
It goes as usual.
No, but in our case, we have a really ugly monolith, and basically the only way to get into the build fast is to throw raw CPU power at it.
Yeah.
Is there any, are there any ways to improve, or optimize for monoliths? Is Google considering doing that?
To what, sorry?
To optimize for monoliths? Have some other sort of mechanisms where you keep something and you fetch it, or you...
No. Between two executions, all your stuff is trashed.
Makes sense.
It's a preemptible temporary environment each time you execute a build. So there is no way of caching, and it's inside the contained environment because we're running untrusted code on Google infrastructure. So Basically, it's a VM with Docker inside of it, which runs Docker. And then when the
Cheers.
build is executed, the VM is trashed. So that's how it goes.
I didn't think about that, actually.
Could you use a private
Sure.
build machine?
Yes, there is something called private workers, but you have to talk to somebody in sales to get those.
Okay.
Because actually, Cloud Build, sorry, I'm jumping on the
No, it's
Cloud Build is gonna be replaced eventually with Cloud Deploy, which is the new product. So, well, not replaced, but it's Cloud Deploy is complementary thing. So it's only a fully managed solution. Just me personally, when I had to work with Cloud Build, I always used to use it as a CI pipeline, never as a CD.
Mhm.
Because, like, typically, like if you want to do a very simple build, human verify deploy, you can't do it with Cloud Build. Or you will have to set up a trigger which automatically triggers to build the code, upload the manifest somewhere, and then have a human trigger a second pipeline to do the deployment.
Yeah.
Right. Which it's not nice. Like for example, you have Jenkins, you just have like a approve button, and then it just continues. Right. You can, for example, break a build and have a human look at it and say, okay, this is going good. Continue.
we think it's fine anyway. Okay, yeah.
Yeah.
good,
So
yeah.
Cloud Deploy is the new product that will have all these capabilities.
Ah, okay.
So if you want to use, if you want a very basic, as you said, very simple to start with CI, Cloud Build is great.
Yeah.
If you want something similar to Jenkins, with all the crazy stuff that Jenkins can do, Cloud Build doesn't do that.
Counterpoint.
No, I'm just gonna make life really difficult for you now. I want something similar to Azure DevOps Server.
Yeah, no, it's not. It's Cloud Deploy. It's the new thing. It's Cloud Deploy.
Anyway, I just wanted to mention one more thing. If you, despite all this, try out Google Cloud because you think I need to save some time, I have a small build. It's not a monolith, right? When you do your testing inside the build, which you really should, I think, then you will have problems because your current working directory isn't where you think it is. And remember the bearded man from 2 years ago. There was something about the directory and testing. Okay? And here's like how, if you can see this, what you would see would be like, please remember to have a directory thing for when you do your testing. So here is where you should run this command, which shouldn't be needed, but there you go. And I should know more about this, but I only know this, and this is the small thing I give you before I sink down to the waves. And yeah, and also the one nice thing with Kaneko is that it includes building and pushing to the Artifactory. So you don't need a separate Docker container started up and do the push. So that's also nice. I think this is nice. Yes.
Is it possible to have infrastructure as well, like deploy the infrastructure first, then parallelly, or not parallelly, just concurrently, we'll have all the code pushed to the build agent and do all the builds and go from there?
I'm sorry, could you say again?
It's like doing the infrastructure deployment first, then next step will be like doing the build process, test, and maybe release.
Right, you don't have the infrastructure. But I
How
think it could be
often
part of it. Yeah.
do you change the infrastructure? Just as a,
Uh,
for my,
I don't like we don't do that usually. Like, but like I just wanted to know, like, let's say if suppose platform team wants to make some security changes in the configuration, so at that point of time, it will be require like entire thing to like go and see and you will also like verify whether all the stuff is, if that still stuff is already exists, not created, else create that stuff sort of.
I have no idea. Counterpoint.
No, it's more like couldn't you cheat because because it already supports multi-stage builds, so you just have one Docker image just runs the script.
Yeah, you can do that.
for Terraform?
Yeah, but
Okay.
exactly. But you see my point. You could cheat and basically you get it into the
You could
system.
also have your own custom builder. So that thing that's so the name, the gcr.io blah blah. So that's the actually
The container.
that's the container that will execute that step. You can have your own. You can have a custom builder essentially. So you can build a Docker container, be in a custom builder with all your custom scripts.
You could have Minecraft. It's
Yeah,
like
you can run a Jenkins inside.
Yeah, yeah.
And inside Jenkins, you can.
Run
I like how you think.
Yeah,
Azure
and
DevOps,
then
run
inside that you can
Kubernetes
have
cluster.
SQL CI,
Yes.
and
Yeah, definitely you can cheat by.
Yeah, but back to your point, actually, there is a valid reason to do that. So one of the things that I have done in the past with people, with customers, is because Kubernetes, when it evolves, sometimes they just randomly duplicate APIs. and you want to make sure that your deployment pipeline will not be backward incompatible. So one of the things we have been doing with a lot of customers is have like an entire pipeline that basically spin up an entire infrastructure similar to production, deploy the app to it, do some tests, and then destroy it. So that we can always deploy on new version of Kubernetes, and then if something goes wrong, we can detect it and fix it in the code. So there is valid reason why you want to do that.
What if your code is not running on GK or Kubernetes?
It could be running on anything, on VMs or on anything. Yeah, you could use Cloud Build to do that. It's just that if you want to spin up infrastructure from Cloud Build using Terraform, it's going to take 2 hours to run. So
50% of me is like, I'm so glad I don't need to do these things. And 50%, I'm so envious of you guys doing these things. So anyway, thank you for listening to me and for my TED Talk. And yeah, you can clap now. We survived. Yes.